this video, we will discuss Section 4-4, Part 2, Day 4, Introduction to Factoring. In order to factor when A equals 1 and C is negative, you first have to list all the numbers that multiply to your value of C. And if C is negative, that means it's going to be either a positive times the negative or a negative times a positive. Then you need to determine which number adds to the value of B, or the middle term. And then lastly, you can fill those numbers into your factors, filling in the blanks next to the x's. So for our first example, we have to find all the numbers that multiply to the negative 15 and add to the value of B, or positive 2. So if I start by listing all the numbers that multiply to negative 15, I can start by doing negative 15 divided by 1 gives me negative 15. So I have 1 and negative 15. Then I want to check the negative version. So negative 15 divided by negative 1 gives me positive 15. So negative 1 and 15. Then you can do negative 15 divided by 2. Gives you a decimal, so it doesn't work, neither with the negative version. Negative 15 divided by 3 gives you negative 5. So you have 3 and negative 5. And then if you check the negative version, so negative 15 divided by negative 3 gives you 5. So you have negative 3 and positive 5. Then I can check negative 15 divided by 4 gives you a decimal, so it doesn't work. And the next number we would check would be 5, which is already here, meaning that we've already listed all of our factors. So now if I want to see which two numbers add to equal 2, you're going to check each combination. So if I were to add 1 plus negative 15 gives you negative 14, then negative 1 plus 15 gives you 14, 3 plus negative 5 will give you negative 2, and negative 3 plus 5 will give you positive 2. So the question is asking us to determine which set of numbers add to positive 2, and looking at our list, we have negative 14 doesn't work, 14 doesn't work, negative 2 doesn't work, but positive 2 does, meaning that the set of numbers that works is negative 3 and 5. So if you fill in your factors, we can fill in the first number is negative 3, so I can fill in a minus 3, and the next number is the positive 5. So I can fill in a 5, and because it's positive, it assumes it's x plus 5. So your answer is x minus 3 times x plus 5, which, again, if we wanted to use the commutative property, you could flip the order, so it could also be written as x plus 5 times x minus 3. However, you only need one of these answers. For the next example, it's asking us to determine, first, all the numbers that multiply to the last number, or the negative 30, and all the numbers that add to the middle term. However, since there isn't a number in front of the x, it's assumed that this really is a 1, meaning that you want all the numbers that add to equal a value of negative 1. So if we start by listing all the numbers that multiply to negative 30, we can start by doing negative 30 divided by 1 gives you negative 30. So you have 1 and negative 30. Then you change the sign, so negative 30 divided by negative 1 gives you positive 30. So negative 1 and 30. Then you can check negative 30 divided by 2 gives you negative 15. So 2 and negative 15. Then you can check the negative version, so negative 30 divided by negative 2 is positive 15. Then I can check my next number is 3, so negative 30 divided by 3 is negative 10. So 3 and negative 10. And I can change my sign, so negative 30 to check the negative, divided by negative 3 is 10. So negative 3 and 10. Then my next number will be 4, so negative 30 divided by 4 gives you a decimal, so it doesn't work, and neither with the negative version. And negative 30 divided by 5 gives you negative 6. So you have 5 and negative 6. And now if I check the negative version, so negative 30 divided by negative 5 gives you negative 6. So you have negative 5 and negative 6. And the next number we would check would be 6, which is already here. Meaning I've already considered all the possibilities. So now, if we want to figure out which of those numbers adds to equal negative 1, we're going to check for each pair. So if I start by doing 1 plus negative 30, gives you negative 29. And then if I do negative 1 plus 30 equals 29. Then you can add 2 plus negative 15 equals negative 13. Negative 2 plus 15 equals 13. Then you can add 3 and negative 10, so 3 plus negative 10 equals negative 7, or negative 3 plus 10 equals positive 7. Then you can add the 5 plus negative 6 equals negative 1. And the last one, which this should have been a negative 5 with a positive 6. So if I add negative 5 plus 6, gives me positive 1. So if I were to write down all and check which of these possibilities works, going down the list, we want to figure out which one of these pairs added to negative 1. So negative 29 doesn't work, 29 doesn't work, negative 13 doesn't work, 13 doesn't work, negative 7 doesn't work, 7 doesn't work, negative 1 does, and 1 doesn't. Meaning that we have this 5 and negative 6 as our set of numbers that work. So if I'm filling this into my terms, I can fill in the first number is 5. So I fill in the 5 and it's going to be plus. And I can fill in the second number, which is negative 6. So it'll be minus 6. So your answer would be x plus 5 times x minus 6, which, as we've discussed previously, you could have also written it as x minus 6 times x plus 5. But again, you only need one of those possibilities. In the last example, you'll notice that we're missing a term. However, we still have to have that middle term. We can rewrite it as x squared plus, because there is no number there, we assume it's a 0x minus 25. So now I want to list all the numbers that multiply to negative 25 and add to equal 0. So if I'm listing all the numbers that multiply to negative 25, I can do negative 25 divided by 1 gives me negative 25. So I have 1 and negative 25. Then negative 25 divided by, I can check the negative version, so negative 1 is positive 25. So negative 1 and 25. Then I can check negative 25 divided by 2 gives me a decimal, so it doesn't work, neither with the negative version. Negative 25 divided by 3 is a decimal, so it doesn't work, and neither with the negative version. Negative 25 divided by 4 is a decimal, so it doesn't work, neither with the negative version. And negative 25 divided by 5 is negative 5. So we can list this as 5 and negative 5. Now, typically our next step would be to check the negative 5. However, we can see we've already done that, meaning that we're done. So if I want to figure out which set of these numbers adds equals 0, I can check each possibility. So I can add 1 plus negative 25, which equals negative 24. Then I can add negative 1 plus 25, which equals 24. And my last pair of 5 plus negative 5 equals 0. So if we're checking to see which set of these numbers adds to equal 0, negative 24 doesn't work, 24 doesn't work, but 0 does work, meaning that we can use 5 and negative 5. So if I fill in my factors, I can fill in the first number is the 5, and since it's positive, it becomes plus 5. And the next number we have is the negative 5, which becomes minus 5. So your answer is x plus 5 times x minus 5. And as we've discussed before, alternatively, using the commutative property, we could have also written it as x minus 5 times x plus 5. However, you only need one of these two answers.